Hello YouTube viewers, welcome to my show Science Thursday. In today's episode we're going to continue our topic on water, and today we're going to talk about rainwater harvesting. So let's dive right into it. Now first, the basic water cycle. So what the hell is this? Basically basically any type of water that you know about, or you hear or you use, is basically coming from either from rain or from snow. That's the only source of water on this planet. Now how the heck that water is coming there is basically solar energy. Sun is like desalinating the water from the sea. So the water is clinically, basically it's a distilled water. However, because of the air pollution, it sometimes gets contaminated. And not to mention, you're not supposed to drink, let's say rain is happening, you should not, okay, first rain, you should not ever drink that water, because it's absorbing the lot of contaminants in the air. Once it has rained for, let's say, 10 to 15 minutes, then the water is like quote unquote safe, quote unquote. Basically it's not going to kill you very quickly, but however, if you have industrial area nearby, it will increase the acidity in the rain. So now again, it's not like it's actual acid where it's going to fall on you and burn your skin. It's not like that, but over time it will cause damage. So it is relatively clean water compared to, let's say, river, because rivers have hundreds of tons of garbage poured into it. So rivers are contaminated beyond belief, and sometimes groundwater is also contaminated by other things like arsenic, heavy metals, and things of that nature. So relatively speaking, rainwater is quite clean, and it's very easy to basically filter it to potable water standards legally. So this is the water cycle aspect of it. So you can't talk about water, rain, and all that without talking about global warming. Now let's say whether you believe it or not believe it, you don't have to worry too much about it. All it will do, basically all the global warming will do, is change the weather pattern. Now this is the weather pattern of India as of now. I do not know how it's going to change in the future. So you can see the blue areas are basically heavy monsoon areas. So monsoon area hits this part, and all that. Now generally the preferred architecture we have, basically the system that we used to have for 150 years, is basically monsoon will come from this side and it will condense in the Himalayan regions. That's how our glaciers are recharged, and they will slowly flood the seas. I'm saying, basically they will slowly flow into the rivers, and river will flow into sea. So that was the old architecture. However, at this point in time, our rivers are drying up, and this is happening planet wide. Almost every river is drying up, literally every river. And if you didn't have dams and all that, you will literally be surprised how quickly all the rivers will evaporate. So rivers are gone because the basically monsoon is still happening. That's not happening because global warming will cause more rain. So why the heck recharging? Because the temperature there, basically the Himalayan region, is no longer cold enough for ice fall. So what happens is, basically rain basically condenses before it's supposed to freeze, and basically it's like a premature, basically that's what's happening, and it causes flash flooding because too much basically what's supposed to become a solid thing, instead of becoming solid, becomes a liquid. So it floods very quickly, rather than acting as a buffer where it's like, okay, a lot of water has been collected into ice and it's slowly melting. It's like boom, it's like it's directly flooding the system. That's why we have very bad floods nowadays, because of global warming. And rain is becoming unpredictable. So basically all our environmental models are very accurate now, but problem is they are not matching up with the past system. And I'm not talking past system, oh last year it was different. No, it's like past system of 150 years of data. It's not matching up. Now our satellites are very good. That's why we can practically trace, okay, this is the tornado here, it's gonna go here and it's gonna hit here. But it's no longer affected because monsoon cycles are changing, and that affects the agriculture industry, that affects the water availability. So this unpredictability literally makes a scenario where, like, places in India in last 2-3 years getting flooded, even though they're not supposed to be flooded, like Pune and all that, they barely get it flooded. Like from past 10 to 100 years, they are like, flooding was like a minor thing for them. Now it's like flooding is so dangerous, it's destroying buildings. So that's what's happening because of global warming. It's changing the pattern, and all our rivers are gone simply because Himalayan is no longer cold enough. And literally the whole glaciers have been removed. There is a hill city that people go for tourism, and I also went there, Manali. Basically it had milestones. Every few steps there was a milestone, and in milestone there was a rating, like January and June. So the idea was, in June you should not cross this milestone, and in June basically summer milestone and cold winter milestone. So in winter you're not supposed to go inside, like basically deep inside the mountain range, because there's too much snow, too much avalanche and all that. So now here's the deal, that milestone happened before I even saw the snow. Now the driver told me, yeah, you will see basically 10-15 of this, because year by year it's going so far back that like literally you can see in 1980 it was here, in 1950 basically 2000 it came here, 2010 it came here. Like it's hundreds of kilometers, basically hundreds of kilometers of ice is disappeared, hundreds of kilometers. It's not like 1 kilometer or 2 kilometer. So even if we had a random like very deep cold, it's no longer able to recharge it. Basically we have depleted it way too much. So flash floodings are becoming very serious now. So what is the science behind of rainwater harvesting? Science is basically simple. Anytime you drill into the ground or any type of well, it's groundwater. Now where the hell groundwater is coming? It's basically coming from rainwater harvesting. Now the reason why this natural cycle is no longer happening is simply because we blocked it using concrete. Every time you pour concrete, the ground is no longer absorbing the water. Now earlier in early like 1990s, it was not an issue simply because we still had lot of wetlands. Now wetlands is kind of contradictory, it's paradoxical, because you will see them and you will like, hey, I don't think this can absorb water, but turns out they absorb water far more efficiently than deserts. So if you have a lot of rainfall in desert, you will have flash flooding. If you have a lot of rain in wetlands, it will absorb surprisingly large amount of water. So once people started pouring concrete over these places, basically people started buying lands and building buildings there, then water had no place to go. So that created a scenario where runabout, basically rain happened, water supposed to be going into the ground, it did not went into the ground because of the concrete, and like it flowed. Now again, it had no place to flow into unless there is a river nearby. So that basically caused what we call dangerous runabouts. So basically randomly people can be driving in the car and voila, like a whole area can be flooded. And that's why you're getting flood warnings very regularly. It's like, okay, it's been raining for 2 days, flood warning. It's been raining for 1 week, flood warning. Now in older times it was like it took very long time because we had wetlands, and of course wetlands also have a limited capacity. It's not like unlimited, but it took very serious stress to overload them. Now it's like flash flooding. Like that's why flash flooding is becoming so common nowadays everywhere. Like you can be driving and like whoosh, flash flooding. So because we applied concrete everywhere and there is no place for water to go. Thankfully, we have already applied the concrete. So that only means in very low cost, like relatively very cheap pipes, I'm talking PVC pipe, nothing fancy, nothing complicated, you can literally divert the water where you want it to go. And whenever you talk about rainwater harvesting, people will give you a very large sum of money. It's like, give me this much, $10,000, $50,000, or $35,000. You're like, why the hell it's so expensive? The rainwater harvesting part is cheap. That's free. That's almost free. Like if you're building the building itself, you don't even have to pay specific. Just tell the basically architect, hey, do rainwater harvesting. They won't even charge you extra. Of course, some extra plumbing, pipes and all that, but nothing fancy. However, to store that water, rather than recharging it to the ground, storing it is the expensive part, because you have to buy tanks. Now again, that's up to you. Many times people use these tanks just as a basically buffer. Because if you live in a scenario where rain is not continuous, basically the worst rain I know is like continuously for 3 days. Like that's the worst rain I know. But there are places in India where it rains for like 1 week or 2 weeks. There it's useless. But let's say it rains like for 3 days continuous. I will build a system that can absorb 3 days of water. Because if you directly try to recharge that amount of water, land still needs time to absorb it. So this acts as a buffer. It's like, okay, rain will fill it up very quickly, but it will slowly drain into the groundwater. So your groundwater will be slowly recharging, and groundwater will be able to absorb it. And sometimes people directly use it. It's like, okay, just build a system, no groundwater recharging, just use it. Groundwater recharging will only happen if it is overflowing. So that's up to you. This is the expensive part. Plumbing, pipes, filters, all that, those are free, relatively speaking. You don't have to worry about it. This is one of the only things that you can talk about waters, and it's like actually affordable to most of the people. And if you're doing like big things, like, you know, you want proper filters, you want proper plumbing, you want proper tank system, and sometimes people have multiple tanks. Basically they will have one holding tank, then they will have one sedimentation tank, then they will have one like final storage. So again, the cost could pile up, but even at worst case scenario, the cost never exceeds basically a small car, like a very small cheap car. It's not very expensive thing. So you can easily do it like by saving up some money. Like raw rainwater harvesting, that's very easy, but the storage, that's up to you. So what we can expect in the future. Now this is one of the only times I can make a video about things, and don't be depressed about it, because simply this is the one of the problem that we are solving, and we are doing it very well. So because people are waking up, if we had done this before we like started to pour concrete everywhere, we would not even have to worry about water. No place on this earth is like will suffer water, except unless you are in desert, except there. Like this will not work in Israel, but in India, there nobody would even think about water crisis if you had done that, and it would not have cost costed us too much, because at the early days we did not have to worry about like doing what we call storage of rainwater. We could have simply done groundwater recharge. If we are everybody who's building the new buildings, then the groundwater recharge, we will never have to worry about it, never. And because it is DIY friendly, basically I have provided links below and you can check a lot of those videos. So people are doing it themselves. People are now awake. It's like, okay, now we have to do something, and people are doing it themselves. It's not, people have done it for as less as like $5, $10, and some people are like spent like let's say $10,000, and they're like in a desert, and it rains enough. It's supposed to rain some amount, it rains enough, and it's like, yeah, our whole year is taken care of from that water itself. So you have to understand, it is a feasible thing, it is a cheap thing that you can actually do. So, and government is everywhere, almost everywhere in the world is like, okay, every new building must have it by default. Like Indian government is slowly brick by brick making it mandatory for new buildings flat out, and old buildings, they are like still struggling whether we should make it mandatory on the old buildings or not. But at this point in time, this problem is solved for the new buildings, and it's actually cheap. So like you can see, like villages in India is doing it, like people in Kenya are doing this. It's not an expensive solution, it's an actual thing that you can be like, hey, let's do this, it will work, it will help you. Now again, if you expect like you did rainwater harvesting and your dried bowl well will fill up quickly, no, it will not. It will take time, 2 to 3 years. And again, let's say I did the rainwater harvesting, it will barely slow down my drying up the bore wells, simply because there are like at least 10 bore wells in less than 10-meter radius, because we are like very packed environment. So all of them also have to do rainwater harvesting. So I have to do lead by example kind of scenario, where I have to do it, then ask them to do it. If they don't, then I have to invest in storage. It's like, yeah, I can't recharge it because like you're gonna drain it. So again, it is a problem that can be solved. It is a problem that can be solved affordably. It's not like, okay, yeah, you, let's say there is a drought in Chennai, like it's a big metropolitan in India, and it's like, okay, build a desalination plant. Again, it will solve the problem, but it will cost like hundreds of millions of dollars, $400 million to be exact. So okay, rainwater is one of the cheapest solution, and it can like flat out eliminate basically water crisis. Like many places in Delhi did it on themselves, not relying on municipality and all that. They came together and they did it, and here's deal, they no longer even have to have water logging issues, because water being placed into places where they want it to be, underground. So this is a problem that we can solve, this is a problem that we are solving. So this is one of the things which give you hope. Like if this is done correctly, and like over time, people will not worry about basically a water crisis anywhere on the earth, basically, except a very large metropolitan city like New York and all that. They will need desalination system, but other than that, most people will be more than like well enough. So this was my basically presentation on rainwater harvesting. I hope you liked it, learned from it. In that case, please click the like button. If you didn't like it, or disagreed with it, you can press dislike. I would urge you to press it twice to show me your extra disappointment. And please leave a comment, because I reply to all of them. Watch all these videos and subscribe. Press the bell icon if you're free. And as always, thanks for watching.